slowly more rigorous. An idea that I want you to get firmly in your mind, because I'm going to ask you questions about it. I guarantee you're going to have a chance to tell me about this. Central tendencies. Two big ideas that I want you to get your minds around. One, central tendencies. The other's variation. You have to understand those two key ideas to make sense of data. Central tendencies, well named. It's what values, what scores do individual subjects tend to cluster around. And the notion is there should be naturally occurring clusters of scores. The average. It's the classic example of it. So that's central tendency. I'm going to talk more about that in a moment. The other is variance. How much do individuals vary? And how much do they vary on the average? And there's an important reason for wanting to know that. So there are three, believe it or not, when we talk about the averages, there's three kinds of average. Mean, median, mode. The mean is just the mathematical, the arithmetic average. You take the total number of subjects, you divide the scores, so you add up all their scores, you divide by the number of subjects. So if I wanted to figure out what the mean height was in this class, I would add up all your heights, so, well, pound, add it up, I would get a summation, and we call this summation of x. X is being the scores. And then I would divide by n, which is the number of you, and that gives me my score. So you're how many inches tall? 72. Everybody's going, oh shit, math in my head. He has no idea.
I'm 5'8".
All right, so 12, 5, that's it. All right. So we could add up all these inches and get some weird number of inches, really high number, divide by 1, 2, 3, 4, 5, 6, 7, 8. Boom. That gives us our number. So we would know what the average height was. Now, this just to foreshadow why variance becomes important. In this group, this sample, I could use you and get a reasonable approximation of how tall the average AUM student is. You're kind of an okay group for that. But imagine I had in the group maybe a couple basketball players. Right? And so we've got somebody who's, let's say, vertically challenged and somebody who's very tall. They're not very representative. That's variance. Individuals are different from one another. And one of the things you need to understand is the more variance we have, the more people we need in our sample for it to be one that will be what we call representative, to give us good information. The median is the score at which half the values fall below, half fall above. Half above, half below. And the mode, I love that, the mode, is the score that occurs most frequently. These are all averages. And so you have to watch out, because if you ask somebody, well, what's the average price of a house in this neighborhood? Depending on what stakes I have in the game, I might choose any of these. And most of the time it won't matter, because normally these central tendencies are pretty well in the same ballpark. But suppose that I am in a house, I'm in this neighborhood, and part of the neighborhood is a trailer park, and part of it is a subdivision of a golf course. That average isn't going to tell me much. Now, the median, where half fall below, half fall above, might. But realize you need to know all three of these scores to really know what's going on. So let's do, I want to just do an example here that we're going to keep coming back to. This is a thought study. It's one of the favorites in my head. And in our thought study, we are going to, and there won't be a page for this in your printout, so you won't find it. Imagine that we want to know the effect of alcohol consumption on the balancing ability of pirates. And so what do pirates drink? They drink grog. And it's a fairly small boat. We only have 11 pirates. So we'll see what they do. So we're going to just go and see how long they can stand on one leg. And for some pirates, that's going to be a problem because that's going to leave them on a peg leg. So they're going to have, some variation. We're also going to get variation from other things. And this is what happens. Like, some of the pirates are going to be kind of chronic drunks. So they're going to have more tolerance. And some are going to be bigger than others. So they're just going to be different in how they can handle the drinking. So, with that in mind, let's do this. Let's start Pirate 1. Oh, I messed myself up here. Okay, that's all right. Was able to balance for 55 seconds. Pirate 2, 69 seconds. 3, 56. 65. 45.
Number 5 sucks.
Oh, yeah. Where was I at? 45? 48. 38. 34. 25.
These guys need to start drinking more and build up their tolerance.
45. Okay, I've lost somebody here. Hang on. 55, 69, 56, 65. Yep. See if this works. Oops. Ah!
You haven't missed
How do you know?
anybody.
You need to count again. Let's see. Who did I miss? I missed my 45. All right.
I think it might be easier just to erase it.
I know, but I'm figuring this thing out. All right, so 65, 60, and 45. All right, we got them. We're there. So this is just there are individual measures on how long they are able to function that way. So I need to shrink this up just a little bit to give me some more space here. Whoop. Try this again. Guess I should group these guys. All right, so we got them grouped up. So we know that our number is 11, right? We'll double check here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Using our Arabic. I love that. I can't say Arabic numbers. All right, so what we would do then is we would add up all of these. We get our summation of x. And who's done that? Who's figured it out? It's 540. So I can take our summation of x. Our number is 11. And what does that give us? Hmm? 49?
0.09.
Okay, she's going 2 decimal points over. Fantastic. Does anybody disagree with that number? All right, so that's our mean. By the way, you'll often see that as represented as X bar. That's a useful thing to know. It's one of those pieces of knowledge in life that people just assume you know without ever telling you, and you're just always, that's the stuff that just drives me bonkers, is the crap they just assume you know without telling you. So we've got that, and I'm going to take just a minute here to figure this out. So this guy had 1 drink, 65 seconds, had 2, 60 seconds, had 2, 56, had 3, 55, where's my 55? Had 4, 48, had 3, 45, one of them had 3, the other one had 6, 38, had 4.
These pirates are lightweights.
This one had 7 and 5. All right. So now we have number of drinks and time. Now the problem with this, one of the many problems with this study, is number of drinks is not a very good measure, because some of these pirates, again, are going to be of different sizes. So what we would really want would be something like blood alcohol content, right? That would be probably the best measure. But this is what we have. We're talking about pirate balance, for Pete's sakes. Grog is good enough. All right, so you might imagine, and this is not going to be a very exciting graph, but it's going to help us in a minute, so we'll do it. But you can imagine a graph like this where we want to do a frequency distribution. So we want a relative mapping of where everybody's at. To do that, the first thing I want to do is organize these in a rank ordering. So if I rank order, I'm going to end up with the highest score, 69. What's the second highest score? 65. Then 60. 56. What's next?
55.
55.
48.
48.
45. 45.
45.
38. 34. And 25.
You're fast. That takes me forever. I have to go. All right. So now we know that 49.9 is where our mean is, right? Our mode, just for, oops, that's not what I need. Let's undo that. I don't know why that. Our mode is 45, right? Anybody disagree with that? And then our median, just so that you know, is, going to be around right here. So you can see.
The middle number. So in this one, you've got 11 numbers. It'd be, you find the center number, and then you have 5 on one side, 5 on the other. So that'd be your median. You've got 5 on the bottom of 48, 5 on top of 48.
Yeah, basically you write down all your numbers and do it smack down in the middle.
Yeah, but
No math involved.
You put in order. 48 falls dead center. Therefore, it's your median.
oh, okay. I thought there's 5 on top and 5 on bottom.
There are.
Because there's 11 scorers.
Like, for
No,
instance,
there's 6 on bottom.
no, there's
No,
not.
you don't count the median. The median's in the middle. You got 5 below the median and 5 above the median.
Take that line that goes through 55, 48, take it out. You're looking at 48, and you count 5 underneath it and 5 on top of it. And then if you had an even number, like you had 10, then yours would be, say, take one of the 45s out.
Ah, I got it.
Oh,
You're wrong.
okay.
Now, notice there's only one of these values that has to actually exist in the sample, which is what?
The mean.
The mode. Why? Because it's the one that occurs the most often. The mean, well, I guess the mean can be a number that doesn't exist as an actual score. The mode can be as well. We have 11 here, so that makes it easy. But if we had a middle number, we would have to do some math to sort it out. Now, I may ask you to recognize mean, medians, and modes. So the other thing, too, is we're going to do this frequency histogram sort of thing. Sounds fancy, doesn't it? And so 20, 25, 30, 35, 40, 45, 50, 55. How far do I need to go to 70, don't I? Uh-oh. 60, 65, 70. And this is why I love this thing. There. All right. So what I want to do then is just come and graph on every one of our scores. So it looks to me like I need a box at 25 and 34 and another one at 38. And ideally those would all be level, but they're not. 45 has 2. 48. Oops. Has 1. 55 has 1. 56 has 1. 60 has 1. And 69 has 1. So this is kind of a boring distribution, but I need you to understand how we got here, because as we move to bigger samples, this will become more interesting and more important. Even so, we can still see that our mode really is a pretty good central tendency measure, isn't it? Because it's pretty close there. Our mean ends up being here. Oops, X bar. And you get, boy, I'm just not, I should never be given a class before 10. There we go. X bar's right there, mode is here, and the median is, I think, right here. So we've got that. Does everybody understand that much? Everybody be comfortable with the opportunity to do one of those? All right. Easy enough. Now we get a little more complicated. Remember I told you we needed to understand that frequency histogram to understand some important concepts. So one really big idea for us is going to be a notion of a normal distribution. Who's heard of a normal distribution? Nobody's heard of the normal distribution? How many have heard of a bell curve? Who's heard of curving grades? All right, finally. All right, so it's a little disappointing because the one thing you know about the curves is wrong. Now, how many of you suppose you would like in the average class to have your grades curved? No one wants it, right? People think they want their grades curved until I explain to them what that means. And here's what a curve would mean. It means I would take the scores from the exam and I would force it in such a way that half of you did better than the other half. In this class, it means like maybe a third of one person would get an A. A third of one person would get an F. There'd probably be a B and a D, and everybody else would be C's. No matter whether the high score was 50% or 100%, that's what would happen. And I'll show you how that works. So imagine if instead of studying 11 pirates, I had a study where I had 500 pirates. What might happen, and this of course is not drunken pirate data, but it's close enough, what might happen is something like this. In fact, I would expect something like this to occur. Each of my score bins would have progressively more people in it. Does everybody understand how that would work? And there would be measures of central tendency. More people would have a score that was kind of average. And as you go further and further and further out, you would end up with this bell-shaped distribution. Now, this is a pretty cool thing because this bell-shaped distribution, we see it over and over and over again in the natural world. We can count on it. I love this screen. It's just fun. You can't do that with chalk. All right, so we end up with this distribution. It's a Gaussian curve. It's the bell curve. We see it for virtually every phenomenon we measure. Reaction times to alcohol and other drugs, you'll see something like this. Intelligence test, you see something like this. If I had a class large enough of Gen Psych students, I would see something like this. But you have to have a lot of people for this to work. And this distribution has some fascinating properties that you should know about. So right here is the mean, right? Does everybody understand that's where the mean is? All right. So I can now take, I got my one, and draw a line right there. 50% of the scores fall above that number, 50% fall below. In a true Gaussian distribution, mean, median, mode are exactly the same. They're perfectly the same. Now, this is an interesting thing. Go around and ask everybody you know, do you consider yourself to be above average or below average? You know, intelligence, whatever. Are you better than the average person on your job or worse? Almost everybody thinks they're on the sunny side of average. But that can't be. That's not possible. Half the people are worse than the other half. Half the people are brighter than the other half. It's just how it is, right? So that's a problem. But here's what else is really interesting, I think, about this distribution, and you should think this because you're going to be tested on it. At predictable levels, I don't like that. Let me, where's my, there we go. We really kind of run out. There's a better figure that's in your book. At what we call standard deviations, and this is a measure of variance. Remember I talked about variance as being real important? You'll see standard deviation. I want to know how much the average person is different than the mean. So suppose we're measuring IQs, and let's say that the average intelligence is 100, which guess what? It is. How about that? The average person is about within 15 points of that. Why do I say that? Well, within one standard deviation, above or below the mean, we have 34%. So I also have 34% here. In the next standard deviation over, 14% of the population falls, then 2%, and then it's this is like less than 1. So, I mean, like itty bitty small part. Functionally, what that means is I can't remember to push buttons. Sorry about that. And I'm not sure if your book gives you this exact diagram, so kind of, I guess I can just pull this down. So what this means is, if you have, there's that first group there, and then it's a little funky. Let me get this down a little tighter. So if you imagine this line I just drew over the top encompassing those two 34% pieces, that means that 64% of the population is that close to the mean. Oops, I do mean 68%. Thank you. And then within this range, how many? It's 95. And then if you go out one more so that you get these three pieces, you're talking about over 98%. Now what this is real important, because if I have two pieces of information, the mean and the standard deviation, and then I have someone's individual score, I can tell you what percentage of the population they are above and below. So, as an example, in IQ, the mean is 100, the standard deviation is 15. So if I have an IQ of 115, I am one standard deviation above the mean. If I have an IQ of 130, how many standard deviations? 2. And what percentage of the population am I brighter than if I'm 2 standard deviations above the mean? 95%. Actually, yeah. Actually more than that, because you have to add in those other pieces. So remember, this is information that holds true across any distribution that looks like this, and almost all distributions do. This is going to become real important. This idea is real important if you want to grasp inferential statistics when we talk about things being statistically different. So here's the thing. If I want to compare two groups, I don't know how representative they are, and if I just have the means, I don't have their variance. So again, imagine I have another class, same number of people as you. We do the height thing again. The other class has one person who is 7 foot tall. Can we compare your means? We can. The means alone are going to be confusing. They're not going to be that meaningful because their variation in that class is going to be higher. Okay? Because our 7 foot guy is going to be way out here. So this will make more sense as we go on here, hopefully. And so for those of you who are wrapped up in math and want to know the equation, she's going, yeah, please let us do this. These are the equations so you can figure out variance and standard deviation. I'm not going to ask you to, but sometimes people are interested in how that comes about. It's really a kind of a straightforward process. And if you're going to be a psychology major, you're going to see this equation. You shouldn't get freaked out. It's a very simple one. If you know how to do sums, division, square roots, and squaring, you should learn. Then this is really pretty easy. I think it's. I'm trying to remember when they teach that. It's like sophomore high school, something fairly early.
That was like over a decade ago.
Right. So it's back here, but it's easy to figure out. It would take you about an hour to go through. If you didn't remember any of it, an hour sitting down with somebody could explain it to you. These are on the online notes, so we're just going to move on.